Today's lesson is section 5.1, the unit circle part 2. Now, like we were talking about before, remember initial side and terminal side. Now we're kind of switching it to initial point and terminal point. So here, remember reference angles? Reference angle was an angle that, given a certain quadrant, it was always in between 0 and 90, and it was always a number that would refer you back to the first quadrant, to those values you already have locked down. So here we're doing the same thing, except they're called reference numbers because we're using along or going along the unit circle with our t value, our radian measurement. So we're just calling them reference numbers because a radian measurement is a number, not really an angle measurement. We use them for angle measurements, but it's really more talking about the distance around the unit circle rather than the angle at which inside from the origin. Okay. Reference number. Let's let t be a real number. The reference number t bar associated with t is the shortest distance along the unit circle between by t and the x-axis. So that's the same thing with our theta and theta bar. When we were talking about angles or reference angles, there's always the shortest angle from the x-axis to your terminal side. Okay, so here, your first quadrant, remember that your t, your regular angle, or your regular radian measurement, and the reference number are going to be the same, so you don't have to do anything because they're equal to one another. Second quadrant. Now, the shortest distance would be coming from the negative part of the x-axis to that point. So we would need to find the reference number from our regular t that we have. We need to take pi minus t. That's the same thing as like 180 minus t for the last chapter. Quadrant 3. Here, the shortest way is just to start from the negative x-axis to that reference number, or to that point, terminal point. So we would want to take t minus pi. That's the same thing as our theta minus our 180 degrees. And then fourth quadrant, it'd be faster to go just in a negative direction to that point. So to get the reference number there, you would need to take 2 pi minus t. That's just like saying 360 minus theta. Okay, so they're all very similar. They're just inserting in radian measurements rather than degree measurements. So, using that, example 4, we want to find the reference number for each value of t. So t, let's say, is 5 pi over 6. So we need to first locate what quadrant we're in. Okay. So if we're looking at the unit circle, we talked about this one last time. It's in the second quadrant. So since it's in the second quadrant, I need to do pi minus my t value. So t is 5 pi over 6. Now I can change pi to 6 over 6 and subtract. So that gets me pi over 6. That's the same thing as like 150. So 180 minus 150 would get you 30 in degrees. And so 5 pi over 6 is like the 30 of the second quadrant. Okay, next one. Here you have 7 pi over 4. Okay, so in the first quadrant you have pi over 4, second quadrant 3 pi over 4, third quadrant is 5 pi over 4, and then the fifth quadrant, or sorry, not the fifth, the fourth quadrant, you have 7 pi over 4. So you'd be stopping right there. So since you're in the fourth quadrant, I need to take 2 pi minus my t value. So here I need to make common denominators. So the 2 becomes 8 over 4. So subtracting gives me pi over 4. Because it's like the 45 of the fourth quadrant. Okay. Now letter C, because you're going in a negative direction, we need to first change negative 2 pi over 3 into a positive to apply these ratios that we've been using, like the pi over minus t and the 2 pi minus t. We gotta put it in the correct quadrant. Even though you could find the right quadrant, those values wouldn't work the same way. So first I want to add 2 pi to get it in between 0 and 2 pi. So let's change it to 6 pi over 3, add, that gets me 4 pi over 3. Okay, so now 4 pi over 3, well, there's 2/3, pi is 3/3, so then that must be right there in the third quadrant. Okay, so in the third quadrant, that tells us that we need to do our t value minus pi. So our t value now is 4 pi over 3 minus pi. We just said pi is the same thing as 3 pi over 3, so subtracting equals pi over 3. Okay? Now we want to also be able to use our reference numbers to help us find a terminal point. Okay, so let's say we have a t value of 11 pi over 6. First you want to locate that quadrant. So 11 pi over 6 is more than 6 pi over 6, which is more than 9 pi over 6, the same thing as 3 pi over 2. So then it's got to be in the fourth because it's less than 12 pi over 6, which is 2 pi. So it's in the fourth. So let's take 2 pi minus 11 pi over 6. I'm going to make 2 pi into 6, so it's the same thing as 12 pi over 6. So it gives me pi over 6, but because you are in the negative point, remember that your y values are negative. So the pi over 6 point for the first quadrant is going to be square root of 3 over 2, comma 1/2. But because of the 1/2, or the y value being negative in the fourth quadrant, I need to tack on a negative sign to my point. So then my point for this 11 pi over 6 should be square root of 3 over 2, comma negative 1/2. Same thing here. Just like the negative 2 pi, I need to change this first. So I'm going to add 2 pi to it. So that makes it 6 pi over 3. That gives me 2 pi over 3. That's a coterminal angle, or coterminal radian measurement. So then now, so if I go to have pi over 3 in the first quadrant, so 2 pi over 3 is in the second quadrant, because pi is 3 pi over 3, so it's less than that, so it must be in the second. Okay. So then now, since I'm in the second quadrant, I need to do pi minus t. So like I was saying, pi is the same thing as 3 pi over 3. So subtract gives me pi over 3. Now the point for pi over 3 is 1/2, comma square root of 3 over 2. But since we are in the second quadrant, my cosine or my x values are positive and my y values or sine values are negative. So then I need to, switch that around. My cosines are negative in the second quadrant. My sines are positive in the second quadrant. So then I need to tack on a negative to my cosine or x value. So I should get negative 1/2, comma square root of 3 over 2. Okay? So lastly, we'll talk about just a refresher of the definition of trig functions. So let's say let t be any real number, and let p of x, comma y, so your terminal point, be the terminal point on the unit circle determined by t. So depending on what t is, the p point xy will be on the unit circle somewhere, depending on how far it is around the circle. So here are your ratios. Remember, sine is your y value, cosine is your x value, and then tangent is y over x, cosecant is just, I forgot something there, 1 over y, okay, secant is 1 over x, and cotangent is x over y. Remember, cosecant, secant, or cotangent are the reciprocals of the ones above them. And remember that also means that you can't have undefined functions, so that's why I have the y cannot equal 0 and the x's can't equal 0. Let's make that correct. Y can't be 0 there. Alright? And here's a fun picture for you. Okay? Have fun.